Consider a major city, its skyline a testament to human ambition and engineering prowess. Every morning, millions cross its rivers and highways. A complex network enables them: bridges, tunnels, roads. These are the arteries of the city, essential for its economic life, essential for daily routines. Yet many of these structures show visible aging and strain. Commuters feel daily friction and congestion, a constant reminder the infrastructure is struggling. The system is visibly under pressure. The need for expansion and repair is undeniable. The municipal government publishes detailed financial reports. Tucked inside those pages, significant funds remain unspent. On the left, a modern city skyline with heavy traffic on an aging bridge. On the right, a close-up of a government budget report with a highlighted line item showing unspent infrastructure funds. The money is there, sitting in accounts, earmarked for bridges, earmarked for transit lines. The budget appears healthy. The resources seem available. Political leaders publicly declare the will to act, yet the work does not proceed. This pattern appears in developed nations. It also appears in developing nations. A high-speed rail line stays a dotted line on maps for decades. A planned port expansion stalls in studies and reviews. A needed power grid upgrade sits stuck in planning. The gap between identifying needs and completing projects can stretch years or decades. This lag persists despite understanding the economic cost of inaction, and despite financial capital being available. So the issue is not only lack of resources, nor merely failure to recognize the problem. The deeper mystery lies in the system itself. Why do delays repeat with such regularity even when consequences are tangible and funds exist? What unseen forces and hidden dynamics turn planned progress into prolonged stagnation? To understand why delays occur, we must first define the system itself. The term infrastructure refers to the fundamental physical and organizational structures needed for the operation of a society or enterprise. These are the networks that form the backbone of the modern economy, enabling the movement of people, goods, energy, and information. They can be broadly categorized into several key domains: transport, energy, water, digital. The successful operation and expansion of these systems involve a diverse cast of actors. Governments typically initiate and oversee large-scale projects. Private contractors are the builders. Financiers provide the enormous capital required. Regulators ensure projects comply with established standards and laws. Lastly, the public acts as both the end user and a key stakeholder, whose support or opposition can significantly influence a project's trajectory. These participants form a complex web of relationships, interactions, and dependencies. The scale of these systems is immense, and their planning horizons extend over decades. An investment in a new subway line is not just a response to current congestion. It is a bet on the future growth and shape of a city for the next 50 to 100 years. Similarly, the construction of a new power plant or a national fiber optic network is based on long-term forecasts of economic activity, population growth, and technological change. Unlike consumer products or business services that operate on short cycles of innovation and replacement, infrastructure assets are designed for longevity. Their very purpose is to provide a stable, reliable foundation upon which other economic and social activities can build and flourish over generations. This long-term nature means that the system is inherently slow-moving and resistant to rapid change. The system is designed for stability, not speed. This inherent inertia is a crucial feature to understand. It is not necessarily a flaw, but a fundamental characteristic of building things that are meant to last. It is within this context of immense scale, diverse actors, and long-term horizons that the process of bringing a project from an idea to a functioning reality unfolds. The journey of an infrastructure project from a mere concept to a physical reality follows a structured, multi-stage life cycle. It begins with the planning phase, where the need for a new asset is identified. Population growth, aging existing facilities, a desire for economic expansion. During planning, agencies conduct feasibility studies. They analyze potential costs and benefits, and explore alternative solutions. The output is a detailed proposal. It outlines the project's scope, the objectives, and a preliminary budget. This initial step can itself take several years. Once deemed viable, it enters the funding and approval stage. This is where the plan meets finance and politics. Public projects often require legislative approval. They may seek public funds, private investment, or loans from international development banks. Securing capital is a critical checkpoint. No physical work can begin without it. Simultaneously, projects must navigate regulatory approvals, environmental impact assessments, land acquisition permits, zoning clearances. Each approval involves multiple agencies. Each is a potential delay or halt. With funding secured and permits in hand, the project moves into construction. This is the most visible stage. Designs are finalized, contracts are awarded, and the physical building begins. This process can last from a few years to over a decade for major projects. Finally, upon completion, the project enters the operation and maintenance phase. The new bridge opens to traffic. This includes routine inspections, preventative maintenance, and eventual repairs. This entire life cycle, from the first glimmer of an idea to decades of operation, is the standard pathway for building the systems that support our world. One of the most frequently cited reasons for infrastructure delays is a straightforward lack of money. These projects are exceptionally expensive undertakings, often requiring billions of dollars in capital. Public funds are finite, and they must be allocated among competing priorities such as healthcare, education, and defense. When economic conditions worsen, tax revenues may fall, leading to budget cuts. That can directly impact the capital available for long-term construction projects. This narrative of financial scarcity is a simple and powerful explanation for why a planned project may fail to move forward. The process of securing financing can itself be a major source of delay. However, this explanation is not always complete. As noted earlier, there are many instances where funds have been successfully allocated and are sitting in government accounts. Yet projects remain stuck in limbo. The money is present, but it cannot be spent. Furthermore, in an era of historically low interest rates and a global search for stable, long-term investments, there is often a significant amount of private capital actively looking for infrastructure projects to fund. The challenge, it seems, is less about the absolute availability of money and more about the bottlenecks that prevent it from flowing into actual construction. Therefore, while funding shortages are a real and significant hurdle, they do not tell the whole story. It is an important piece of the puzzle, but it is just one piece. Beneath the surface, causes of funding and management lie deeper, structural drivers of delay. The first is a fundamental mismatch between political timelines and infrastructure timelines. Political leaders typically operate on short election cycles of 2 to 6 years. Their goal: demonstrate progress and deliver tangible benefits within that window. That creates a strong incentive to favor visible, quick projects. In stark contrast, major infrastructure projects run on decades. The leaders who approve a project probably won't cut its ribbon. Benefits often arrive long after they've left office. That creates a structural bias against transformative investments. Instead of fully replacing an aging bridge, governments choose short-term patches. Those repairs solve immediate problems and win headlines. But they don't fix the underlying structural decay. They're political solutions, not engineering ones. Consequently, approved large projects are vulnerable to shifting political winds. A new administration can pause or cancel a predecessor's project. Stop-and-go funding is wildly inefficient. It demobilizes contractors, creates investor uncertainty, and adds big costs every restart. The project becomes a political football. Progress is driven by the rhythm of elections, not technical need. The consequences of persistent infrastructure delays extend far beyond the project site, creating powerful ripple effects that dampen economic activity across the entire system. When transportation networks are unreliable, the cost of moving goods increases. These added costs are ultimately passed on to consumers, imposing a hidden tax on the entire economy. The impact is also felt in lost productivity. An unreliable power grid can force factories to halt production, discouraging new investment. And delays in digital infrastructure create a drag on innovation, causing the economy to fall behind regions that have invested more effectively. Beyond the economic costs, the systemic delay in infrastructure renewal has profound social consequences, often exacerbating existing inequalities. Lower-income neighborhoods are more likely to be served by the oldest and most poorly maintained water pipes, increasing the risk of contamination. The quality of one's environment and access to basic services becomes increasingly dependent on one's zip code. When climate adaptation projects are delayed, it is often these same communities that are most exposed to the risks of flooding and other hazards. This quiet accumulation of infrastructural debt represents a transfer of liability to future generations, who will inherit a less functional, more expensive, and more fragile world. We have journeyed from visible symptoms to the hidden machinery that drives them. The true problem is not isolated failures, but a coherent system structured to produce delay. These drivers compound each other, creating powerful inertia that is difficult to overcome. Surface causes, lack of funds, cumbersome regulations, poor management. These are visible symptoms of deeper interacting forces. We must shift perspective, stop blaming individuals, examine the rules of the game. Delays are a logical outcome of the system we designed. This is why delays quietly bankrupt infrastructure. Lasting solutions require rewiring the system itself, changing decision-making rhythms, reforming procurement rules, investing in better data. However, implementing them brings a final, unresolved tension. All involve spending more today to avoid far larger costs tomorrow. This creates a difficult political and social choice. It forces a direct trade-off between the present and the future. Who should accept the certain costs of today to prevent uncertain, though likely larger, costs tomorrow? Should today's taxpayers pay more for a bridge that will primarily benefit the next generation? There is no easy answer. The tension between short-term needs and long-term responsibilities remains the ultimate barrier to breaking the cycle of delay. How societies resolve this tension will determine the future of the systems they depend on. You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.